All right, let's consider the curve defined parametrically by these two equations. And this goes from 0 to pi. If you want to get a visual for it, feel free to graph it. I'm not going to. We want to find the highest point on the curve and justify our answer. Okay, well, now you could graph it, but that's not a good justification. Maximums and minimums occur where the derivative equals 0. Find the derivative. Well, let's do it. The derivative of y with respect to x, this is first derivative issue here, is going to be, well, derivative of 2 sine t would be 2 cosine t divided by the derivative of this guy, which would be 2t, and that just gives me cosine t over t. So that is my first derivative, and what I want to do is set this equal to 0 and decide where does this, well, equal 0. So if you want to bring the t up by multiplication, you can. I'm just going to think of it logically. If a fraction equals 0, it is the numerator that equals 0, as long as the numerator and denominator are not simultaneously 0. So basically, cosine of t would equal 0, and where, and it looks like cost equals 0, and at what t value would this be true? Well, where is cosine equal to 0? And you could think of a lot of places, but we're only going to use a domain from 0 to pi. So it's pi over 2. Okay, so here's what just happened. We found a potential critical point. Now, we're going to use the second derivative test, and it's going to be absolutely wonderful. So let's doodle for just a second on a Post-it note. You got a function. You have a function, it's not even called a function. You have something that's defined parametrically like this. We're going to do that. And I find the derivative, and the derivative gives me set the derivative equal to 0, and it gives me a point or another point. And those points are going to be potential maximums or minimums where my derivative equals 0. If I know the concavity at those points, concave down perhaps, then I'll know it's a maximum, or if I have concave up, it's a minimum. This should sound familiar, it's just in a different context. So let's keep moving. I need to find the derivative of the derivative. Again, we're going to go back to this big idea right here, that right there. So take the derivative of what you found, divide it by dx dt. So we're going to take the derivative of the derivative. So dd t of cosine t over t. Yes, that's going to involve the quotient rule. I'll divide it by the dx dt stuff, which was 2t. Okay, and you could say, oh, it was just t when we reduced it. No, let's go back to here. And again, just the derivative of that. Okay, so a little bit of quotient rule in the numerator. So f prime g. So let's put the g in the front. There we go. G minus f g prime is 1, all divided by g squared, divided by 2t, so I'm going to call it 1 over 2t. Ooh, all divided by g. Nope. I about overdid my quotient rule there. We've done our quotient rule. Sorry, I was getting ahead of myself. So this was the quotient rule, divided by 2t, I'm going to call it 1 over 2t, and this is going to give me negative t sine t minus cosine t, all divided by 2t cubed. Okay, fun times. So I want to know what the concavity is here. I want to know what the concavity is here. So, yeah, let's do it. In order to do that, I need to plug in the right t value. And, well, I say here, I mean t equals pi over 2. So I want to find the value of the second derivative at t equals pi over 2. So we're going to do this mostly without a calculator. So negative pi over 2 times sine of pi over 2 minus cosine of pi over 2, all divided by 2 times pi over 2 cubed. Let's keep going. All right. Cosine of pi over 2 is 0, so with a big red pen, let's just go ahead and mark him out because he's not going to impact our lives. Sine of pi over 2 is 1, so we really have negative pi over 2 over 2, okay, let's do a lot in our head. This is pi cubed over 8, but 2 to the third, but that 8 gets reduced with the 2, so there's that. And at this point, you could stop. You could be like, man, I don't know how to reduce this, and don't make your life complicated. I want to know about the concavity of this. Is this entire thing positive or negative? We have a negative divided by a positive. That must be negative. Therefore, I'm just going to start writing the explanation. Here we go. The second derivative is negative at t equals pi over 2. So, this coordinate is a maximum. Have I found that actual coordinate? No, actually. Let's put the word max right here. So I got a little bit ahead of myself there and did not even know the actual coordinate. So find the highest point. That's a coordinate. So let's find it. I still need to know what goes here. Let's switch colors. Let's go to green. And I want to know what the actual coordinate would be. So I'm going to plug in pi over 2. So x of pi over 2 would be pi over 2 squared minus 5, which is pi squared over 4 minus 5. And then I want to plug in this, which is going to give me 2 sine of pi over 2. Sine of pi over 2 is 1, so that'd be 2. So final answer is the justification where we found the highest point. Because the second derivative is negative at that t value, we have this coordinate written in the wrong color. Oh no. As a maximum. Okay, now things get really fun. We want to find all points of inflection on the curve and justify our answer. Oh, okay. Points of inflection occur when you cross, let me rephrase that, when the sign of your second derivative changes. I want to know where the second derivative sign changes. So let's find out where the sign of the second derivative, well, changes. Let's go. Here it is. I'm going to type, and now I'm in function mode at this point. So if you're like, oh, I need to go into parametric mode, no. Don't. You have all the tools you need in function mode. Let's go to function mode, and I'm going to type, let's clear it out. I'm going to type that second derivative right there. It's going to be x's instead of t's, but we'll deal with it. So negative, parentheses, negative x sine x minus cosine x divided by 2x cubed. There we go. Let's put that in parentheses. By the way, if you do my little trick of x for x cubed, things fall apart if you're dividing. So let's put parentheses. So it's not much of a trick. It's actually the lack of shortcut, but whatever. I want to go on the appropriate window with my domain. However, consider my domain is from 0 to pi, and I would be dividing by 0 here. All right. Now, my function, my parametric equations, do have a domain that really does begin at 0, but the second derivative, actually the first derivative, doesn't even exist there. So it's not differentiable at t equals 0, I should say. So when I press window and go from 0 to pi and try to adjust my window, I'm going to go zoom fit, which is zoom 0. Then I'll wait a second. Looking, there we go. Okay, I got a whole lot going on down here that I really don't need. So I need to chop some of that off. I'm going to start maybe about here. I don't know where here is, maybe about 1/4. So let's go to 0.25 and adjust this. The x minimum should be about 0.25. So zoom fit that. Okay, still better, yeah. So I know it's approaching, it's going up, and so I've not really missed any x-intercepts. That's what I'm looking for. Again, let's not lose sight of what I'm doing. I want to find the points of inflection. Points of inflection is where the sign of the second derivative changes. And so we graph it as a function, find where the sign changes. See where we cross the x-axis. Cross, but not necessarily just touch the x-axis. Okay, I don't see anything fantastic and beautiful happening before x equals 1. So window, let's go from 1 to pi, and we'll graph that. Maybe we can find it. There we go. It's going to be a little bit better. And it happened there. Okay. I'm going to make this a little bit clearer. I want to go from, this is the only place, only one answer. This is the only point of inflection. So it's from 2 to 3. It's somewhere in between 2 and 3. I'm going to adjust one more time. That might be a waste of time. From 2 to 3. Zoom fit. And then we'll be able to find it. We're going to find that 0 and then write it out as an explanation. Okay, let's find that point. Second calc, 0, left bound, looks good. Go to the right. Get there slowly. Looks good. Enter. That's it. 2.798. Fantastic. Found it. Let's write it down. T equals 2.798. I just wrote the wrong thing. I said one thing and wrote something else. I was looking somewhere else while I was writing. That's a bad idea. 2.798 is the only t value where the second derivative changes signs. Okay? And that is my only point of inflection, and that's why.